In this Godot tutorial, I'll teach you how to create an authentication process so that your players can log into your multiplayer games. This tutorial will take large-scale multiplayer games into account because that's what this series is all about. Let's get started. I wish just for once that I could create an easy tutorial, teach you all about authentication in 15 minutes. But I can't, because before I can teach you proper authentication processes, we have to talk a little bit about network architecture. And these couple of minutes are probably going to be the most important minutes of this entire multiplayer tutorial series. So hang on to your hats, and it might get a tiny bit complicated, but I'll drag you through it and you'll thank me in the end probably. So when you started this tutorial series, or when you landed on this video in YouTube, you probably had something along the line of this in mind when you thought about multiplayer in games. A number of clients connecting to a single game server with a database, and everybody's happy. Well, not so much, because there's a number of serious problems with this architecture, even if you can talk of architecture with something as easy and simple as this. And two of the most important problems that I'll want to highlight here is first, scalability. A single ENet protocol Godot high-level multiplayer server is capable of handling up to about 4,000 concurrent connections. 4,000 concurrent connections is a major achievement for any indie dev developer. However, if you reach that success, you want to ride the wave of success, so you want to make sure that it's scalable and you can add more servers. Otherwise, you have a number of players, dozens, maybe even hundreds, that are facing a login attempt failed servers full message. That's the last thing you want when you ride that wave of success. So you need scalability. The second one is that this game server is connected to the internet. But it's also exposed to the internet. What I mean by that is that that game server needs to be able to accept any IP address as a connection, because any IP address is a potential player. And with all IP addresses being accepted, you also expose the database which holds the user data, email addresses, usernames, passwords to the internet. Now, that doesn't automatically mean that they're accessible and that everybody can just look them up, but it does reduce the amount of layers of security we can implement within this architecture to make sure that we as game developers take our responsibility to keep the private data of our players safe. And that is an important responsibility to take. So let's switch over to what we're going to be teaching in this entire tutorial series and how the architecture will look. This is what we will be programming in this tutorial series. And I know it looks like a lot, but don't worry, don't run away. We'll take it nice and easy, step by step, authentication first. But before I can teach you that proper authentication, I do need you to abstractly understand what's going on in this little schema here. So I'll take 1 minute of time to explain it, and I'll make a separate tutorial video on where I go really into the why and the how and the what of this network architecture, and also show you some slight variations that might fit the type of game you're making a little bit better. The authentication part is going to be staying the same in all those iterations that I'll be showing, so don't worry about having to redo or undo things. That shouldn't be the case. So without further ado, the clients are going to be connecting to the gateway. The gateway is exposed to the internet, accepting any IP address. The gateways, plural, because you may want to have several gateways, maybe one for the Americas, one for Europe and Africa, one for the APAC area. That way you can reduce latency. The gateways are going to be connecting to the authentication server, forwarding that login request they received from the client. Now, the authentication server is only going to be connecting to a number of gateways and a number of game servers. And because of that, those limited connections, and of course we know the IP addresses of those servers and gateways, we can use IP filtering in the firewall of the authentication server. Thereby we don't expose it to the internet. Now, that doesn't mean it's absolutely 100% secure. There are things called IP spoofing, where you can fake an IP address, but it is yet another layer on top of other layers that we will be implementing for security to make sure that we don't lose any data that we shouldn't be losing. And that's really how network security works. It's not like a one-size-fits-all solution. It's really layer upon layer upon layer upon layer to deter those that would like to get unauthorized access to our servers. So The authentication server is of course going to do the actual authentication process. So it's going to be matching username and password with a database of usernames and passwords. And on successful authentication, it will generate a token, and it will send that token to both the game server and the client. So it will communicate back through the gateway to the client, successful login, and this is your token, and it will tell the game server you can expect a connection with this token. So that token is going to be time-stamped by the authentication server, and it will only be valid for about 30 seconds or something like that. Next, the client will try to connect to the game server, and the game server will match the token the client provides with the token it receives from the authentication server. Thereby, it can be assured that that client has just been authorized by the authentication server to log in. If the client is too late, or if you would have somebody try and use the same token a second time, a couple of minutes later or next day, or try and send it to your friend to also log in, you'll see that the token has expired and is no longer able to be used. Thereby, we secure our network. So with that said, we now can have a look at what we got so far from episode 1 and 2 and what we have to be doing in this episode to get that authentication working. In the last 2 episodes, we coded the client side and the game world side. So we already have 2 executables. Now we have to also be programming a gateway and an authentication server, bringing our project up to 4 different Godot projects. That is going to be a little bit more complex, but once you have the gateway and authentication server established, usually you don't really have to work on those that much anymore. They are pretty lean in terms of coding, and you can afterwards focus again on your game server and your client. Now the challenge of this tutorial is that if you have, for example, a look at the gateway needs to be able to have both a server connection, as in the clients are going to be the peers, the gateway is the server to which the clients connect, but the various gateways are then pairs of the authentication server. So we need to establish 2 network multiplayer ENET nodes within one single executable running at the same time. That is really the challenge of this tutorial and what I'll be teaching you today. So we are going to be solely focusing on the authentication part, the token with the timestamp and that being sent to the game server to have that verification process. We'll leave that for another tutorial, so we really focus on authentication today. Okay, back in Godot, time to code. I've already, as you see on the bottom, got 4 Godot executables. So that's the first thing you have to do. You have to make 2 extra executables, one for your authentication server and one for your gateway server. Now I've already coded everything in, and we're going to go over everything step by step. If I were to code live for you in this tutorial, then this tutorial will be an hour long and you don't have the concentration for that. So the first thing we'll focus on is the connection between the authentication server and the gateway. That is going to be a very standard connection that you already know, because it's exactly the same kind of connection that we already got between the game server and the client. So we have a very standard piece of code, exactly the same, pretty much a one-on-one copy from what we did in episode number 1. The only difference was that left and right I changed some variable names. So instead of max players, we have max servers, and instead of the pair connected the player ID, now I have the gateway ID that's being connected, and I print gateway with a number connected and disconnected. But like I said, minor changes. Then we can go over to the gateway project. So that was the authentication project. Now we go to the gateway project, and the gateway project, instead of putting the code on the main node of the server, I have opted to actually run them both in a singleton. So I have 2 singletons that are called authenticate and gateway. The authenticate part is the connection to the authentication server, and the gateway part will be what's going to establish the connection to the clients, which we'll get to in a moment. On the authentication part, this also is pretty much exactly the same piece of code as we added to the client side in episode number 1. The gateways are a pair for, or a client, I should say, create client for the authentication server, and we're just going to be connecting to the authentication server on that port number 1911, which is the same as on our authentication server 1911. It gets different when we have to start thinking about the connection between the gateway and the client. The problem is, or the challenge I should say, is that when we create the server or the client, we create the client, for example, right here, and we set the network pair, the network. So the network is our eNet node on which we create a client with this IP address and that port. That's all going to be stored in that network variable. And then we set the network pair to that network we have been defining. Now that set network pair is a function of getTree. What that means is, and this is the back end of Godot explained a little bit, every scene tree comes with a built-in multiplayer API. That multiplayer API is basically responsible for a lot of things, making sure connections can happen, that the connection between or the clients and the server are going to be polling each other, basically shouting to each other, hey, are you still here? And then, hey, yeah, you're still there. So all of that is built in, it's integrated. Now we need this, basically we took this slot already. We took that multiplayer API that comes standard in your scene tree because that's what we need to connect to the authentication server. But now this gateway also needs to become a server for the clients. Like I said, it needs to have that double connection, that double eNet node running at the same time. So for that, we need to go out of our ways and do things a little bit differently, a little bit more complex. So let's get into that. Moving to the gateway singleton, so this is going to be the server side of the gateway that is going to be accepting connections from the client. You can see that things are a little bit different. From the top, we still define our eNet node, but now we also define a new multiplayer API and we store it in our variable gateway API. I now use a new port number, not 1911, but 1910. And I set a maximum amount of players, but that can be up to about 4,000. Then on the start server, we again tell the network that we've defined up there that this is going to be a server with this port number and the maximum amount of players. But instead of using the getTree set network, we now set custom multiplayer. So we set a new custom multiplayer API using that gateway API right there. That is, of course, the new multiplayer API. Now, once we have set a custom multiplayer API, we also have to set the root node. And once you have this line of code, this variable or this parameter custom multiplayer becomes available. So we set the root node because that multiplayer API needs to be somewhere in the scene tree. We can't set it to the root of the scene, but we have to set or define one other node in the scene tree as the root. Now, the singletons, authenticate and gateway, now they're just scripts, but when you actually look at when the client is running, you can see when you go over into the remote scene explorer, you can see that they're actually as two separate nodes in the scene tree. So we're setting the root node of this new multiplayer API to self, which is going to be the gateway singleton. Now, once we have got that, then we set the network pair network to that custom multiplayer. So this line of code is basically the same line of code as we have in our normal server connection when we have this. So here we take getTree, set network pair, and on the gateway we now use custom multiplayer, set network pair. So that's pretty much where we load that network up into the multiplayer API. Now, with that done, we now are running two eNet network multiplayer nodes, high-level multiplayer, basically in the same executable. This, of course, also means that the client needs to be connecting to this. And the client also, of course, on its game server already has that multiplayer slot on the tree in use. That's what it uses to connect to the game server. So when the client also needs to be able to make a connection to the gateway, basically being a client to both of these servers, we also need some separate code for that. So I've made a new singleton in the client called gateway, same name. I'm not sure if that's important for this one, but I think it is, so better make it the same name. And we set the network, the gateway API, the IP address, and the port number. Don't have to look at a username, password yet, and don't have to look at these 4 lines of code yet. We'll get to that in a moment. So we're going to start right here. We take the create client, we take the network, we create a client, we again set customer multiplayer, we again use that gateway API that we defined on the top there. We again define the root node to self, and we again set that network pair on the custom multiplayer. Thereby, now the client can also connect to the gateway while the gateway is connected to the authentication server, and the client is able to also make a connection to the game server on a separate high-level multiplayer network. Okay, so with all of that set up, we're almost there. The only thing we have to do extra is we have to pull the multiplayer API. That is done by default when you use the get3 set network peer. There's a standard polling sequence happening in the background that you don't have to worry about when you create a simple multiplayer game. But when you have a custom multiplayer API, you need to poll manually. So in the process function, we are polling the custom multiplayer here using the poll function. That is a function of the multiplayer API. Now you can see there's a number of circumstances that we do not want to poll, because this connect to server will only be done once we hit the login button. We'll get to that in a moment. This custom multiplayer is not always set. And if it's not set, there's nothing to poll. And if there's nothing to poll, Godot throws you an error. So we first want to verify if get custom multiplayer is not null, because in that case, we just wanted to return and try again later. Then we also have to make sure that there's actually a network peer, because if there's no peer to scream to, hey, are you still there? And then expecting a reply, then you're also going to get an error. And again, that's not what we want. We don't want errors. It's not good. So also, if there's no network peer, then we're also going to return. And if those situations are not true, then it's just going to continuously poll. And that might sound very intense, but it's not. This also happens in the standard in your standard scene tree. In your standard multiplayer API slot, that is polling all the time as well. So this is not like something weird. This is very standard. We also have to do exactly the same on the gateway. So also in the process function on the gateway, there's also custom multiplayer polling happening. But here there's less circumstances that we would not want that to be going on, because when we start the gateway server, we under the ready function start the server and we load the custom multiplayer. So the gateway always has that custom multiplayer loaded. So there's not a situation where that is not the case. So we need one less exception here, and we can slim the code down with 2 lines. So with all of that said, let's now have a look at actually how the authentication process is going to be going through all these different servers and ending up back at the client with a result. Now, of course, for authentication, we need our player to be able to fill out a username and a password. So I've created this rather easy, simplistic user interface for our login screen. I will not go over how to make this because I'm trying to keep my tutorial shorter, believe it or not. So I'll create a super quick tutorial on how to do this and upload it today or tomorrow in case you don't know, but I assume you do when you're watching this sort of intermediate level multiplayer tutorial. So if we play only this scene, you'll see that here we can fill out a password and a username. Right now the password still shows letters, but if you want that to go away, you could very quickly go to the login screen. You will be able to go to your edit text, and you could set this to secret, and that way you can have all those letters disappear. But for now, for demonstration purposes, I'll keep it open and exposed so that you can see when I'm filling out the wrong and the right password. So this login screen has a little bit of code, not too much. We define the username input and the user password input. So that is basically the 2 text edits that are going to be typing the text in. And we define the login button. We have connected the signal of the login button of the pressed signal, and we've connected it up. First, it's going to be checking whether we've actually filled out a username and a password, because if both or either of the username and the password are empty, that means that we don't have to make a connection to the gateway server, because we can already tell that there's never going to be a positive authentication result. So when you have not filled both of these out, you're not even going to try and make a connection. And we now have here print, please provide a valid username and password. But of course, you would have to program a sort of a pop-up in there to make sure that your player gets the right feedback. Else, we're going to be disabling the login button. We do that, and we disable that button until the result from the authentication server comes back, or when there's a timeout. I've not programmed that timeout in yet, but the reason we want to do that is we don't want somebody to start slamming that login button 100 different times and then having the gateway get all these connection requests and forwards all these authentication requests, and then most likely somewhere in our servers there's going to be something blowing up. As in a bug is going to appear, or an error appears, and that way a player could drag down the whole authentication server. So we don't want it to be able to send 2 authentication requests out at the same time, so we're going to be disabling the login button the moment the player pressed it and there was valid text input. So we define the username as the text box, and we get the text. We do the same for the password, and I've done everywhere in the code, I've done a lot of prints so that we can follow in the editor what's actually happening. So we're printing, okay, we're going to attempt to log in. Then it will call the gateway singleton, and it will connect to the server. So in the gateway, we now have not got on the ready, we don't make the connection automatically. We are only going to be making this connection when the player presses that login button. In the previous tutorials, we have automatically connected to the game server through a connect to server under the ready function. I've taken it out. I've put a comment here, so also we're not automatically connecting to the game server anymore. It's an important note there. Okay, so we're on the gateway. The gateway is going to be making that connection. So it's going to be connecting to the server, and now these 4 different variables, or these 4 elements here, become important. The connect to server is going to be receiving that username and password. That's what we've done in the login screen. When we connect to the server, we push that username and password to it. So we have the username and the password. We define that in 2 variables on the top here so that we can use them later on. And I'll get back to these 2 lines in a moment. So once we have made that connection is either going to fail or that connection is going to succeed. When it's failed, well, we'll print the standard print that we've already had in the previous tutorials. We'll also need some sort of a pop-up with that the server is offline or something, or wasn't able to connect to the authentication server. You need to send a signal to your player like, hey, something went wrong, please try again. Now, in that case, of course, we also have to make sure that we enable that login button again, because else there's no second attempt possible. So we enable that button again. On a connection successful, so that means that the client and the gateway are now in a connection. Only then that signal has been triggered, we can run the login request. So that's actually when we start the communication. And so that happens automatically, but only automatically once the connection is there. Because if we fire the request login before the connection has actually been established, that is going to go and never arrive. So that basically triggers this function, the request for login. So we're doing another print here because all these prints are going to help us with following the signals. Of course, once you actually release your game, remove all these prints because that's just server overhead. You don't want that. We're going to RPC ID call number 1, so that's the server. We're going to run the function login request, and we forward that username and password. The moment we do that, there's not a single reason anymore to retain the username and the password in variables on the top here. Just for security reasons, whatever, I don't know, malware or sniffers or packet sniffers or whatever, I'm not sure what will be able to get it out of here. But if we don't have a reason to have it in there, we shouldn't have it in there. So we're just going to be resetting that the moment we've sent them away to the gateway server. We just erase the variables on the client side. So now that login request goes to the gateway. So we switch to the gateway project. On the gateway, here we have the remote function login request. So that's what's going to be triggering. So we have a login request received. You see, I continue these prints. I will stop mentioning it now. And we basically define the player ID that made the request. Now we're going to get the RPC sender ID, but do take note when we, for example, have a look at the game server that we programmed in the first tutorial. When we receive a remote function, not this one, we need a game server, sorry. When we receive a connection, we define the player ID, and when we define the player ID, we get RPC sender ID. This get tree is that standard multiplayer API that is loaded into the standard slot of the scene tree. That's how this function works. It basically gets the default multiplayer API. So now on our gateway, you can see that we also get that player ID through get RPC sender ID, but we have to take it from the custom multiplayer API. Otherwise, we're gonna get errors, or it returns 0. That's also possible. So once we got the player ID that made the original login request, we then call the authentication or authenticate singleton on the gateway. We authenticate the player and we forward the username, the password, and the player ID. We don't need the player ID anymore in the authentication process because that's just a peer ID in the network. But that player ID is going to piggyback along for the ride, so that once the signal comes back to the gateway, it made that loop. We still know which client was the original requester. So we go to the authenticate script. So that is now the interface to the authentication server, where we run that function authenticate player. This is going to be RPC1 calling the authentication server. It's going to call the function authenticate player with the username, the password, and player ID piggybacking along for the ride. Now we can switch to the authentication server, which is going to be remote functioning this authenticate player. So this script is going to run. So it receives the authentication request. It determines which gateway requested or made this pushed forward this login request, because we need to also make sure once we got several gateways that we send that signal back to the right gateway, because that player ID, that client, will only be connected to that gateway. So we also have to retain the gateway ID. What we want is we want to get some results of this authentication. First is we'll check whether the username exists in the first place. If it doesn't exist, it means that the player doesn't have an account with that username. So either it misspelled the username or it doesn't have an account yet. So the user is not recognized and the results are false. If that is not the case, it will check the password, if the password is the same. If not, then we have an incorrect password and the result is false. And else, we have a successful authentication and the result is true. Now, as you can see, we're only working with a Boolean here. We're not going to send back whether the username was wrong or whether the password was wrong, because that's information that the player doesn't really need. We can just tell the player, look, something was wrong, either your username or your password, please double verify and try again. We don't have to tell them, well, your username is known, but your password is wrong. If we send that information to the player, that if that information is intercepted somehow, that means that we have one less layer of security, because now a potential hacker would know, hey, that's a valid username. Now all I need is the second piece of the puzzle and the password. So it would provide more information to those that have bad intentions, let's say. So we're only going to be communicating true or false, nothing more. We're not going to tell what went wrong or what was false. So once that is done, we are going to take the RPC ID and we use the gateway ID. So we're going to communicate back to the gateway with the authentication results function, and then we communicate the results and that player ID that had been piggybacking along for the ride all along. Then we go back to the gateway. On the gateway, we have the remote function authentication results. Then it will have received those and will reply those to the player. We're going to call the gateway singleton, so we return from the client side to the server side of the gateway, where we're going to run the function return login request with the results in the player ID. We switch singleton under the function here. We're going to RPC ID call the player ID that had been piggybacking along for the ride all along. We return the login request with the results. Then we disconnect that player from the server, so the gateway decides that that player should be kicked from the server. The login request is done, the loop is finished. We no longer need you. Free the space of this gateway for other players to find a connection. That way you can have up to maybe 10 or 20 game servers running, and you only need maybe 1 or 2 gateways, because the gateways will not have the amount of concurrent players that are at that point in time playing the game on the game servers. Otherwise, you would need a hell of a lot of gateways. Anyway, we disconnect the client after we done the RPC ID call. So that means that the call goes out to the client. So the client is going to be on the gateway receiving that signal. Now it receives the results. If the results are true, then we run the game server singleton connect to server. So instead of having the connect to server start automatically under the ready function, this connect to server is being initiated the moment, where were we? Gateway, I'm sorry. The moment a positive result is returned from the authentication server via the gateway. Now, of course, right now, somebody will be able to just adjust this code and just make it connect to the game server automatically. And that is where the token is going to come in once we program that in a future tutorial, it will also connect to that server using that token being received from the authentication server. And that's how we make sure that people cannot bypass the authentication process. Now, if we have a successful result, we no longer need that login screen, that user interface panel. So we're going to key-free that away from the graphical user interface, no longer needed. Else, if the result is false, we probably want to provide a pop-up with please provide correct username and password. Again, we are not going to be identifying what was wrong. We just know something was wrong. Just verify your username and your password and good luck. Then, of course, we also have to be enabling again that login button that we disabled when we pressed login, so that the user can make a second attempt. And we're going to be disconnecting our connection failed and connection succeeded signals that we have set up connected here on the top when we made the connection with the gateway server. We need to disconnect these two signals because if the player did something wrong username, and clicks login again, these signals will try to reconnect again. And when they try to reconnect, the Godot will throw an error saying these two signals are already connected, you cannot connect them a second time. So to make sure that that error is not thrown at us, we have to disconnect these signals here so that they can be reconnected in case the player makes a second login attempt. Did you follow? Probably have to rewind it a couple of times and pause. I understand. So what we'll do now is we'll test it. We'll play it, we'll do it, and I'll show you how it works. So okay, to test this, we'll first have to start up all our servers. So we'll start with the authentication server first. We'll hit play on that, and we have authentication server started here in the output. We'll also run the game server. That's not going to have any connections from the start, but we need to have that running anyway. So here we have server started on the game server. Then we're going to start the gateway. So we press play on the gateway. Here we get a gateway server started, and we get it successfully connected to the authentication server, because remember there's two network ENET nodes on here. And now we can check the authentication server. Now we also have a gateway with this peer ID connected. So that seems to be working just fine. Now we can play the client. And on the client, we can start. Well, let's first check if we only do a username. Let's put the proper username. We forget to put in the password. We log in. We get a message here. Please provide valid user ID and password. That's where we captured it before even sending it out to the server. Now let's fill out a wrong password. So the password, of course, is test123. So we'll do test12. We forgot the 3. We log in. So here we get the whole system. Attempting to log in, successfully connecting to the gateway, results received, please provide correct username and password. That seems to be correct. If we have a look at the gateway, here you also see that we have a user connecting, login request received, sending out the authentication request, results received and replying to the player, and we disconnect the player because that's what the gateway does. It disconnects the peer. If we have a look at the authentication server, we see that authentication request received, starting the authentication, incorrect password, so it figured that out, and the authentication result sent to gateway server. So that all works well. Now, of course, the question is, do we actually, we do have to go into the actual executable in where we played. Can it recognize when we do it correctly? So I'll add a 3. Now we have the correct password. We log in, and now you see at the final here, we have a successfully connected to game server. And now I can simply shoot at this wherever again. And you can see what we programmed in the first tutorial, where the damage is communicated back from the game server, is now working. And we basically have the same situation as what we had after episode number 1 of this series. Only now we have a proper authentication request that lays out the foundation that we need to implement the various security measures and the scalability that are going to be normal for a larger scale multiplayer game. That was it for today, guys. Hope you like it. If you did, smash that like button, hit subscribe. Don't forget that little bell icon to make sure that you don't miss out on any videos. Also, if you want to support the tutorial creation process here at the Game Development Center, make sure you check that join button, what options are available to you. I'll come real fast with that tutorial on the user interface panel, how to create that, although I think most of you will know how to do that. You might be interested in that. If you watch this tutorial more than 24 hours after it has been release, it's probably going to be linked up here somewhere in the suggested boxes. So hope to see you next time. Until then, keep on gaming, keep on coding. See you later, guys.